Teaching techniques. Whenever I do multiples, I would always introduce the multiplication chart for up to the 10 times table. You draw this in a 10 by 10 grid. And as you can see here, the actual numbers we're multiplying are highlighted in yellow, and the answers for the times tables fill out the grid. So for example, 1 times 1 equals 1, and that goes there. 10 times 10 equals 100, and that goes there. By getting students to actually fill out the times tables grid, it helps them to actually recognise what are the different multiples, because effectively they're writing them out. For example, in this row here, we have the 7 times tables, and therefore all of these numbers are multiples of 7. A good game you can play in connection with this is something called Splat Square, which is a game online. What happens is you get a student and you give them a card, and on that card it will say multiples of 6. They then choose a colour, for example, let's say the green colour, and any time that a student says a number that's a multiple of 6, they have to colour that square in with a green splat. Anything that's not a multiple of 6, they colour in with a different colour. By doing this, it not only gets the actual child who's at the board to think about what multiples are, but it's a good investigation for the students who are guessing what the actual rule is, because the more questions they get right, the more numbers they identify that get coloured in the correct colour, they can start to draw links as to why they're all connected. For example, once you start colouring in all the numbers that are multiples of 7, they will quickly realise that what the child has on their square is a rule saying multiples of 7. They would then swap over and get a new card which would have a new instruction, for example multiples of 3, and every time anyone says a multiple of 3 it gets coloured in one colour, everything else gets coloured in a different colour until someone can identify what the rule is. It's a really fun way to engage the whole class and get them thinking about multiples. Deep thinking. To get students to extend their thinking about this topic, they have to start thinking about how they can actually use multiples in real life. For example, in this question, we have to buy hot dogs and hot dog buns. The shop only sells hot dogs in jars of 8 and buns in packets of 6. This causes a problem because you'll end up with 8 hot dogs but only 6 buns for them to go in. How many of each would I have to buy to end up with the same amount of hot dogs and hot dog buns? In order to tackle this problem, the student needs to recognise that this is a multiples question. We have multiples of 8 and multiples of 6. Now there's different ways of representing this. You can do it pictorially and actually show them jars of 8 and packets of 6 and get them to keep working it out until they get to the same amount, or they can simply write out their multiples. For example, if we have the multiples of 8, we would write out that we'd get 8 by buying 1 jar, 16 by buying 2 jars, and so on and so on and so on. So you'd keep on with the 8 times table. Then what we'd look at is the packets. If we are buying packets of buns in packets of 6, the first packet will have 6 in. If we buy 2 packets, we'll get 12, 3 packets 18, and again we continue this on. Now, because multiples can literally go on forever, we would always only do a few at a time until we got to the right answer. Now the question is, what is the right answer? We can see here by listing out some of our multiples of 8 and our multiples of 6 that we can get up to 3 jars of 8 hot dogs will give us 24, and 4 packets of buns will also give us 24. This gives us exactly the same amount in both. However, we can also find that if actually we went all the way up to 1, 2, 3, 4, 5, 6 jars of hot dogs, and 1, 2, 3, 4, 5, 6, 7, 8 packets of buns, we would also have the exact same amount. The question is, when would you stop? Well, realistically, it depends how many people you want to feed. But ideally, you would stop at the first multiple that's the same in both, which in this case is 24. So the answer would be 24. We would need 3 lots of hot dog jars and 4 lots of packets of buns in order to have the exact same amount of hot dogs and hot dog buns.